Guided practice 1. The 7 layers in the sample from a machine have a thickness in millimeters of this data. Find the unbiased estimate of the population mean. B. Find the unbiased estimate of the population variance. Let's put the data in this spreadsheet. Menu. 4. Statistic. 1. Stat calculations. 1. Variable stats. Enter. X1 list. P. Enter. So we got this X bar 6.93. Unbiased estimate of the population standard deviation 0.40644. Control doc. Let's add a page. Add calculator. Click on variables. Go to stat S sub X. Enter. Then square. Enter. We can get more accurate unbiased estimate of the population variance 0.163. If you go to this variance, go to stat results, enter. You could see these results more clearly. So unbiased estimate of population mean X bar equals 6.93. Unbiased estimate of population variance S sub n minus 1 squared equals 0.163. Let's go to guided practice 2. A psychologist records the number of digits of pi that a sample of IB math higher level candidates could recall. We got frequency. A. Find an unbiased estimate of the population mean of D. B. Find an unbiased estimate of the population variance of D. Click on 1. No. 4. Add spreadsheet. This is D. This is F. We have a frequency in this data. Menu. Statistics. 1. Stat calculations. 1. Variable statistics. Enter. X1 list. It's a D. Frequency list is F. Enter. X bar equals 4.63. Unbiased estimate of the population standard deviation equals 1.0987. Control doc. Add calculator. Go to stat S sub X. Enter. Square. Enter. Unbiased estimate of population variance is 1.21. Click on variables. Go to stat results. You could see the results more clearly. So x bar equals 4.63. S sub n minus 1 squared equals 1.21. Let's go to guided practice 3. A manager wishes to check the mean mass of a flour put into bags in his factory. He randomly samples 10 bags and finds the mean mass is 1.478 kilograms and the standard deviation of the sample is 0.0196 kilograms. Find S sub n minus 1 for this sample. We will use this formula. S sub n minus 1 equals square root n over n minus 1 times S sub n equals square root. N is 10. X bar equals 1.478. Standard deviation of the samples is S sub n equals 0.0196. So we do the substitution. 10 over 9 in this square root times 0.0196. Answer is 0.0207. B. Find the unbiased mean of the population. X bar equals 1.478. Let's go to guided practice 4. In a large population of hens, the weight of a hen is normally distributed with the mean mu and standard deviation sigma. A random sample of 100 hens is taken from the population. The mean weight for this sample is denoted by X bar. State the distribution of X bar given its mean and variance. X bar follows normal distribution with the mean mu, sigma squared over 100 as the variance. We got this from CLT. X bar follows normal distribution with mu and sigma squared over n. If the population is not normally distributed, make sure n is greater than or equal to 30. The sample values are summarized by this and this, where X kilograms is the weight of a hen. Find an unbiased estimate for mu. X bar equals sigma of X over n, which is 199.8 over 100 equals 1.998. For unbiased estimate for sigma squared, S sub n minus 1 squared equals, we will use this formula. Denominator, both are n minus 1. Numerator, sigma x squared. This numerator, n times mu squared. Do the substitution. Denominator 100 minus 1. Numerator 407.8 minus 100 times 1.998 squared equals, answer is 0.0869.